So dear students, now in the studies class we have discussed about theorem 3.2. Now let us see theorem theorem 3.3. The theorem 3.3 states that if a transversal intersects two lines, if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So theorem, you look at the textbook, you see in the textbook, I will be explaining what it is. If a transversal intersects two lines, so what is required? Two lines are required, that is A, B, C and D. If a transversal, and we need a transversal, if a transversal intersects two lines such that pair of alternate interior angles is equal, alternate interior angles 1, 2, 3, 4, 5, 6, 7, 8. Which are the pair of alternate interior angle? Angle 4. If the pair of such that the pair of alternate interior angle are equal, that is angle 4 is equals to angle 6 and angle 3 is equals to angle 5. So what he is explaining, if we have a two lines AB and CD, and if angle 4 is equals to angle 6, angle 3 is equals to angle 5, that is if alternate interior angles are equal, so then what? Then the lines AB is parallel to CD. Understood, dear students, what he is explaining? He is explaining that we have a two lines AB and CD. Here we don't know they are parallel or not. Now the condition comes here in this theorem 3.3. The conditions comes here that pair of alternate interior angles, if angle 4 is equals to 6 and angle 3 is equals to angle 5, then if this condition satisfies, then AB is parallel to CD. Okay, if angle A is equals to angle 6, angle 4 is equals to angle 6 and angle 3 is equals to angle 5, that is the alternate interior angles are equal, then the lines are parallel. So theorem 3.3 is a converse of your theorem 3.2. Now let us go for theorem 3.4. Theorem 3.4. If a transversal intersects two parallel lines, if a transversal intersects two parallel lines, the lines AB and CD are already parallel. In the theorem 3.4, if a transversal intersects two parallel lines, that is AB and CD is already parallel and PQ is a transversal. PQ is a transversal. Then each pair of interior angles on the same side of transversal is supplementary. That is if these are the angles, naming 1, 2, 3, 4, 5, 6, 7 and 8, what he is explaining, which are the interior angles on the same side of transversal? Angle 4 and angle 5, and angle 3 and angle 6, right? In the last class we have learnt about this. So what he is saying? He is saying that if AB is parallel to CD, then angle 4 plus angle 5 is equals to 180 degree. That is, interior angles on the same side of transversal is supplementary, and these two angles, angle 3 plus angle 6 is equals to 180 degree. So what it means? Interior angles on the same side of transversal are equal. Okay, that is theorem 3.4. Understand theorem 3.4 once again. Theorem 3.4 explains that if the two lines AB is parallel to CD and a transversal is passing through it, then interior angles on the same side of transversal is supplementary. Means sum of these two angles is 180 and sum of these two is 180. Got it? Okay. Now let us go for theorem 3.5. If a transversal intersects two lines, so it is converse of theorem 3.5. Listen the statement. If a transversal intersects two lines, we don't know whether AB and CD are parallel or not. Okay, just these are the two lines. If a transversal intersects two lines such that interior angles on the same side of a transversal is supplementary, then the two lines are parallel. What it is? Converse of the above theorem. Which are the interior angles? 4 and 5. On this side 3 and 6. He is explaining that in the above figure, if angle 4 plus angle 5, that is interior angles on the same side of transversal, is supplementary, then AB is parallel to CD. Then AB is parallel to CD. Okay. Dear students, a small question I would like to ask you. If A is equals to B and A is equals to C, so can you say that B and C are equal? Yes, very good, exactly. Because A is equals to B and A is also equals to C, it means that this must be equal to each other. So similarly, your theorem 3.6 states that lines which are parallel to the same line, lines which are parallel to the same line are parallel to each other. Let us consider, assume there is a line AB, and let us have another line, that is CD, which is parallel to AB. So what we have now, if CD is parallel to AB, and let us have one more line, that is EF, which is also parallel to AB, where EF is also parallel to AB. So by saying this, what you can say relation between CD and EF? Yes, very good. Then CD is also parallel to EF. That is the theorem statement. He says that the lines which are parallel to the same line, here CD is parallel to AB and EF is also parallel to AB. Therefore, CD and EF are parallel to each other. Got it? Okay, write these theorem statements from the textbook. Write the theorem statements and write these conclusions below the statements, outcomes below the statements. Okay, thank you, have a nice day.